Hello everybody, Mr. Salgado here with the video that you will need to complete the lecture notes for a new section. Now if you remember our last section where we're talking about breaking rocks down into little pieces through mechanical weathering, and we were also talking about converting rocks into new substances through chemical weathering. So we have a rock and you break it down into little pieces. Now the question is, what's going to happen to those pieces of rock? Well, what is nature going to do with them? And the quick answer is that nature is gonna take those pieces and is gonna transport them and is gonna dump them somewhere else. And what is nature going to use to transport these pieces of rock? Well, nature is going to use water. So that's why our new section, the one that we're starting right now, it's running water, because we're gonna talk about how water gets those broken pieces of rock and is gonna transport them somewhere else. And every time that you talk about water, you have to start with the water cycle. So that's exactly what we're going to do. So you guys might remember this question from the bell work, which says, how many times does a water molecule go through the water cycle? And this question was meant to get you guys thinking about the never-ending characteristic of the water cycle. The water cycle never stops. It's been going on for since the beginning of time, I guess. And in class I try to make the joke of the same water that the dinosaurs were drinking thousands of years ago is the same water that we're drinking today, because it's just being filtered. So right here I have the definition for cycle, and cycle is a series of events that are regularly repeated in the same order. So steps that keep being repeated. And for the water cycle, you guys already know the steps, which is evaporation, condensation, precipitation, runoff, infiltration, transpiration, and those are the main ones that we're concerned with right now. So let me just briefly touch on each one of them and explain what they are. So first of all, we have evaporation, and evaporation does not only happen in the ocean, but it could also happen from lakes and rivers. So evaporation is the conversion of liquid into gas. So, liquid water turns into water vapor. And then we have condensation, and condensation is converting gas into liquid. So, the water vapor becomes liquid again, and it's gonna fall down, as rain. So precipitation, it's nothing but another word for rain. The water is gonna precipitate, it's gonna fall down. And once the water precipitates, it falls down, it's going to create what we call runoff. And runoff is, water traveling through the Earth's surface, in the form of a river, and, it's going to accumulate into lakes. And then, once some of the water, it's running off on the surface, but some of the water is going to be infiltrated. It's going to infiltrate into the ground. It's going to go underground. And then, from underground, it'll be taken up by plants. And then, those plants are going to transpire. They're going to sweat. So, they're going to release the water that they took from underground back into the atmosphere. So, transpiration is nothing but the sweating of plants. Now, as a little side note, when you guys were doing your research project, for the brochure and, researching our drinking water here in Rialto, one of the places where, we get our drinking water here in Rialto is from Lido Creek. And Lido Creek is, it's a surface water source. But, about 40 or 50% of our water comes from groundwater. And, so which is water that is underground. So, we drill wells and we pump the water from underground. And one of the things that you guys found out was that at the B.F. Goodrich site, they were creating fireworks, and a lot of the, some of the chemicals they left on the ground, they dumped them on the surface. So, when the water, when it rained, the water, when it infiltrated, it took with it some of those chemicals. So some of those chemicals ended up in the underground water. So, back in 2002, that's when they found those chemicals in our water. And, it was a very scary thing. Now our water is clean. We don't have to worry about that so much. There's still some wells that are still shut down, but they're working on cleaning all those things up. Okay, so if we're talking about the water cycle being a never-ending process, there must be a power source, that's providing the energy for the water cycle to keep going. And you guys already know this. The sun provides the energy, to keep the water cycle going. But the sun, it's not the only source of energy. There's another power that also helps, to keep the water cycle going, which is gravity. And gravity is gonna work on this side over here. And we're gonna talk about gravity later on in this video. But just keep it in mind. So the sun and gravity provide the power to keep the water cycle going, right? Okay, so now this is another picture to illustrate evaporation, and I thought it was a very good visual. You have the liquid water here, and then the sun, lifts up the water molecules into the atmosphere, and then they fall back down. Now, for those of you guys that are a little more scientific, and you guys, like a little more scientific explanation, this is water molecules, and they don't have arms to hold on to each other, but they have positive and negative charges. So they have electrostatic forces that that keep water molecules together. So if the sun provides the energy, and the water molecules are gonna receive that energy, and eventually they get excited enough that they break free from the rest of the molecules, and they become a gas molecule. So because a water molecule by itself is so small and it has such a small density, it's just gonna flow back into the atmosphere. So that's exactly what happens. They're holding on to each other. The energy from the sun comes, and they get excited enough and they break free and go into the ocean, and into the atmosphere. Okay, so how do we know that our water cycle is balanced? Okay, so I have this picture of a balance. If I take 2 little bags of money, obviously this one's gonna go down, this one's gonna go up. So in order to make them the same, I have to put back the 2 little bags of money that I took. So a balance is, means that whatever you take out, you have to put back in. And that's exactly what happens in our water cycle. Earth's water cycle is balanced because the level of the oceans has not changed. It's being constant, it's staying constant. And why does that happen? Because the amount of water that leaves the ocean as evaporation eventually makes it all the way back, through a river, through precipitation, through rain, or through, underground rivers. So our water cycle, is very balanced. Now you have a water molecule here, it goes back into the atmosphere, and then it rains back down into the ocean. Now that water molecule just ended up back to where it started. So it just completed the cycle. So we don't really care about the water molecules that are in this little cycle right here. We care about the water molecules that are dumped on the land, because right here this is where we have our rock, this is where we have our pieces of rock, and this is where the water is gonna transport those pieces of rock. It's gonna take them somewhere else. So we care about this water falling on land and creating runoffs, and runoffs are rivers and streams. So let's talk about rivers and streams. And this is where gravity comes in, because with the help of gravity, rivers and streams are gonna carry they're gonna carry water downhill all the way back into the ocean. So the water that falls on land, it's on a journey all the way back to the ocean. But on that path, on its way back to the ocean, the water is gonna take some souvenirs with it. So what souvenirs is it gonna take? Well, it's gonna take a bunch of sediment and rock with it. So we call that transportation of sediment and rock, we call it erosion. So right here we have a picture of a river, and it's flowing back to the ocean, and as it's going back to the ocean, it's taking all these little pieces of rock and sediment with it. It's eroding the streams and channels. So one of the key characteristics of a river, it's its velocity. Velocity is very important, because the faster the water flows, the more it's going to erode. It's going to transport those pieces of sediment and rock. So we have to look at velocity much close, in closer detail. So let's look at that real quick. So there's 3 factors that determine the velocity of a stream, and it's going to be gradient, channel characteristics, and discharge. So what is gradient? Gradient is nothing but another word for slope or steepness. So you have right here a river, has a slope, it has a gradient, and the question is, okay, where is the water gonna have more energy? Right here where the gradient is very high, or right here where the gradient is very small? Okay, so you can look at the pieces of rock that is transporting. Right here is transporting very big pieces of rock, and right here the little tiny pieces of rock. So therefore, where the gradient is steepest, where you have a steeper gradient, you are gonna have more energy. And you can see the pieces of rock that it's transporting right here. They're bigger pieces. So right here, more energy, more velocity, right? So that's pretty simple. Then we have channel characteristics. So right here we look at the shape, the size, and the roughness of the channel, because that is going to affect the amount of friction between the water and the channel, and therefore it's going to affect the velocity of the river. So when you have a river, okay, where are you going to have the fastest moving water? Is it going to be at the bottom? Is it going to be at the sides? Or is it going to be in the middle? Well, obviously it's gonna be right here in the middle. And why does the water in the middle flow the fastest? Because the water in the middle is not touching anything. It's not rubbing against the bottom of the channel or the sides of the channel. So there's no friction, slowing down the water right here in the middle. So the water in the middle is always gonna be the fastest. That's where you're gonna have your maximum velocity. So now we compare the little river with the big river. Which one is going to be faster? And if you look at the amount of water that this river has, it has a little bit of water. Because it has a little bit of water, most of its water, it's rubbing. There's a lot of friction between the water and the channel, against the ground. So all that friction, all that rubbing between the water and the ground, the channel, it's gonna slow the water down. So this river, the little river, is gonna be very, very slow. Now right here, you look at the big river, and look at the quantity. Look at the amount of water that is not touching the channel, the bottom of the ground. It's huge. Look at all this water that is not rubbing. There's no friction between the water and the bottom. It's huge. So this channel therefore is gonna be faster. So the less friction, the more velocity. So that's why the shape, the size, and the roughness of the channel influence the friction, and therefore the velocity of the river. And then the last one is discharge. And discharge is the volume of water flowing past a certain point in a given unit of time. So you can actually calculate the discharge of a river. We're not going to do it in this class, but it is possible. So then we have that. We're going to bring our pictures back. So it says that the bigger the discharge, the bigger the velocity. So which one is it has a bigger discharge, the little river or the big river? Obviously the big river has a bigger discharge, so this one has more velocity. Now here's where things get a little bit more confusing, because you have a river that is flowing down a mountain, and right here the mountain is very steep, and right here the mountain is very flat. So where are we going to have water flowing the fastest? Right here where it's flat, or right here where it's steep? And obviously you're going to say that right here where it's steep, water, it makes sense that water should flow faster here. However, that is not true, because right here, if you notice, the river is very, very small. So because the river is very, very small, most of its water, it's rubbing against the channel. So there's a lot of friction going on here. So therefore this water, the water, right here on top of the mountain where there's we have a big gradient, is going to be very small. The velocity is going to be small. And right here, where even though the river is very flat and we have a small gradient, but the river is bigger. It has a bigger discharge. So right here at the bottom, we're always going to have, we're usually going to have bigger velocities right here than right here. And like I said, it's kind of confusing, but that's the way things work. So now let's look at the last thing. The best way to study a river is by looking at its profile. And what is a profile of a stream? Is the cross-sectional view of a stream that looks at its source and its mouth. So, it's kind of like a map of, the river from its beginning to its end. And the beginning of a river